A deferred object is really just a wrapper that can be placed around asynchronous processing. Instead of trying to manage multiple success and failure callbacks for a series of asynchronous calls, the deferred object can wrap them all together into a single process that will work regardless of the sequence of completion. There are numerous methods associated with a deferred object. We'll talk about just a few. The jQuery documentation lists all of the methods currently available. Consider the when-then block we've used so far. The when method returns a full deferred object to the code for subsequent operation. We could store this object in a variable and make use of it in various ways. So far, we've just changed some handler functions to the end of the when method and haven't done anything special with the deferred object. That's the most common pattern in use. The thing we need to be aware of is that jQuery is expecting to manage the state of that object for us. If we save the object as a variable, there is nothing to prevent us from altering the state of the deferred object, possibly interfering with the process flow. The promise method returns just a subset of the deferred object that lets us attach handlers like we've been doing, but doesn't allow the state of the deferred object to be changed by us. We'll talk about this a little more in a moment. For now, realize that the promise method does return a deferred object. It's just not one that we can change the state of. Once we have a deferred object, even just the promise object, we can attach event handler functions to it. These functions will be called when the event associated with the name occurs for that object. We've seen the then method in action. It can take up to 3 handler functions as parameters. Those functions associate with success, fail, and progress. Instead of using 3 function parameters, we can use individual methods for each one also. The done method attaches a success handler function. The function will only execute when all processing completes successfully. The fail method attaches a failure handler function. It will execute if there is any error within the processing. This function is only called once, regardless of the number of processing errors that are encountered. The progress method attaches a progress handler function. This is useful if a long-running process wants to report progress completion. This is most commonly used to update a progress bar to give the user a sense of how fast the process is working and how long before it completes. The always method attaches a function that will always execute after completion of the process, whether it succeeded or failed. It's a good place to put any wrap-up code that needs to execute no matter what the results of the processing were. There are 2 primary methods used to change the state of a deferred object: resolve and reject. As expected, the resolve method will change the state to indicate a successful completion, and the reject method will change the state to indicate failure. These methods can only be called upon a full deferred object. They are not available on a promise object. That's why returning a promise to client code is preferable to using a full deferred object. When we use a promise, we know that the client code can't change the state of our deferred object. Even when it's all internal code, it's best to expose only the promise instead of the deferred object, just to be safe. With this latest information, let's go back to our code and make a few modifications. We've changed the then method to use the more accurately named done method. This makes sense because we're also making use of the fail method. In cases where we're only interested in the when and done, using the then method may make more grammatical sense. It's really a matter of preference. Basically, it is better to use when and then in cases where we're only interested in success processing. It's better to use when, done, and fail in cases when we need to handle failure along with success. Notice that we're using the promise method after when. The when method returns a full deferred object that can have its state changed. Putting the promise method in the chain makes sure nothing we do accidentally changes the state. This code processes exactly like our previous code, so why should we take the extra step and use the promise method? The best answer is forming a habit of safety. By training ourselves to make use of the promise, we at least force ourselves to think about it if we decide to remove it. If we never use it, we'll have forgotten about what it does for us, and we may introduce some problems that become very difficult to debug. Remember how the proceed button doesn't get enabled when we have a failure when loading content? Let's imagine that our proceed logic just needs to make sure the loading process has completed, but doesn't necessarily need it to be successful or not. In that case, we can make use of yet another method, always. The always method will run as the last function call once all the success or failure functions are called. This would make a better choice for where to enable the proceed button. Let's remove the code from the done method and add an always method. Let's check our results. It works fine when there's no error. Let's change a content URL to cause a failure. Here again we've changed content 1 to content 11. We see that even with an error, the Proceed button is enabled. Everything is working just like we need. Okay, before we leave this code segment, let's address the burning question on everybody's mind. What's the difference between using the done and fail methods instead of just using callback functions? Aren't they doing the exact same thing? Let's address what a callback function is. It's a piece of code that is passed as a parameter to a method. That code will be called upon completion of some processing accomplished by the method. That sounds exactly like what the done and fail methods are doing, right? Not exactly. The done and fail methods are registering a handler function with the deferred object. There is nothing to prevent registering multiple handlers for the done and fail methods. In fact, if we save the deferred object as a variable, we can attach a handler even after the object has been resolved or rejected. A callback method can only be called once from the original process that received it as a parameter. Assuming we're making a call to jQuery get, if we pass a callback to that method, it will only get executed once the get method completes. There is no way to expand the functionality of the callback after it has been executed because the get method has completed. If we use the deferred object that is returned from the get method instead, we can attach as many done or fail handlers as we wish, in any order we wish, and based on conditional processing. We can even add a handler based on the result of the get. The callback function falls very short of this capability. Let's take a look at some examples to really understand this. First of all, we'll return the page to a working state by referencing content 1 instead of content 11. Next, let's save the deferred object that's returned by the when method. We'll save it into a variable called myDefer. Now, just to prove the point, let's add an additional done method that puts a message in our message area. And now, after some unknown amount of code, we'll add another done handler. We're making use of the myDefer object we saved earlier. An unknown amount of processing happened between the when and then and making use of this object again. It is not part of the chain. It's a whole new set of functionality later in the code. Let's take a look at the results of having 3 distinct done handlers added to the deferred object. The 3 done handlers, one was still empty at this point, were processed in the order they were attached to the object. Once the deferred object was resolved, all 3 done handlers were executed. What would happen if we added another done handler even after the object had already been resolved? It would execute immediately. Let's take a look at that. Let's attach a done handler function from within a done handler function. This may seem to be a very unconventional approach, but it will prove the point of how versatile the handler functions are, especially in comparison to a simple callback function. We'll put it in the first empty done function. To be at this point in the code, the deferred object referenced by myDefer will be resolved. All done handlers will have processed already. The object may seem to have no further use, but we can still attach handler functions to it. Watch what happens when we run this code. Notice how the embedded done handler function was called after all other done handler functions. Since the deferred object was already in a resolved state when the handler was attached, it was executed immediately. This is a very powerful capability of deferred objects. You can conditionally add handler functions to them and have additional functionality occur. Using callback functions to accomplish the same thing would not be nearly as neat and maintainable. This code is easy to read, and each block of code can be omitted or included based on debug versus production states, local versus remote servers, or any number of other factors. Targeting embedded functionality within callback functions is not nearly as simple. We've made use of the deferred object that jQuery provides to us as part of the AJAX method get. There are other AJAX methods within jQuery that also return a deferred object. These methods can be used in the same way that we used get. There is one final scenario we need to discuss, and it breaks our code.